and welcome to day 1 of P.7 Solving Equations. Today we are going to solve linear equations in one variable, solve linear equations containing fractions, solve rational equations with variables in the denominator, and solve a formula for a variable. This is also known as a literal equation. So the definition of a linear equation. A linear equation in one variable x is an equation that can be written in the form ax plus b equals 0. Well, a and b are real numbers, and a cannot be equal to 0. Generating equivalent equations. An equation can be transformed into an equivalent equation by one or more of the following operations. Simplifying an expression by removing grouping symbols and combining like terms. So that's distribution, and then getting everything together on each side of the equal sign. 2, add or subtract the same real number or variable expression on both sides of the equation. Whatever you do to one side, you have to do to the other. Multiply or divide by the same non-zero quantity on both sides of the equation. Again, whatever you do to one side, you have to do to the other. And interchange the two sides of the equation. So there's a couple steps that we need to follow. Solving a linear equation. First step is to simplify the algebraic expression on each side by removing grouping symbols and combining like terms. 2, collect all the variable terms on one side and all the numbers or constant terms on the other side. 3, isolate the variable and solve. 4, check the proposed solution in the original equation. So example 1, solving a linear equation. Solve and check. We have 4 times the quantity 2x plus 1 equals 29 plus 3 times the quantity 2x minus 5. The very first thing I'm going to do with this equation is distribute. So we're going to distribute the 4 to the 2x and the 4 to the 1. And then on the other side, the 3 to the 2x and the 3 to the 5. So I will have 8x plus 4 equals 29 plus 6x minus 15. Because 4 times 2 is 8x, 4 times 1 is 4, 3 times 2x is 6x, and 3 times negative 5 is negative 15. So next step is to combine like terms, and the only place I have like terms is right here, the 29 and the negative 15. And when I do that, I'll get 8x plus 4 equals 6x plus 14, because 29 minus 15 is 6. Step 2 is to collect the variable terms on one side and the constant terms on the other. So what I'm doing here is I'm moving the 6x to the other side. I just have it in line. So this 6x here I'm subtracting, and I'm also subtracting 6x here. What I do to one side, I have to do to the other side. So when I do that, I'll get 2x plus 4 equals 14. The next thing I need to do is move the 4 over to the other side. So that means I'm going to be subtracting 4, because we always do the opposite. So that's why I have a minus 4 here and a minus 4 here. And when I do that, I'll be left with 2x equals 10. So then step 3 is to isolate the variable and solve. So I have 2x equals 10. Divide both sides by 2, so x equals 5. Next step is to check. Now, when you check, all we're doing is putting in that 5 we got in place of these x's here. When you do a check, you can only work on one side of the equal sign at a time, and you cannot cross over an equal sign during a check. So work on the left side, work on the right side, and you can never cross over. So I put the 5 in, so then I'm going to have to do 2 times 5 is 10 plus 1 is 11, and on the other set of parentheses I'll have 2 times 5 minus 5 is 5. So I'll have 4 times 11 equals 29 plus 3 times 5. So now multiply. 44 equals 29 plus 15. And 29 plus 15 is 44. So it checks. Therefore, my solution set is just 5. For example number 2, we have to have an LCD. And in this case, my LCD between 4, 14, and 7 is 28 because it's the smallest number that all three numbers divide into equally. So I need to multiply each term by the LCD. And when I do that, it'll look like 28 times x minus 3 over 4 equals 28 times 5 over 14 equals 20 minus 28 times x plus 5 over 7. 4 goes into 28 7 times. So I'm just left with a 7. 14 goes into 28 2 times. And then 7 goes into 28 4 times. But we have to be careful here because this negative goes along with the 4. Now I just distribute and I will have 7x minus 21 equals 10 minus 4x minus 20. That's after I distribute the 7. I don't know why that line was the same. You don't need that written twice. So after you distribute, be careful that negative goes along with the 4. Now I need to get or combine my like terms, so I have a 10 and a negative 20. So I'll have 7x minus 21 equals negative 4x minus 10. My next step is to get the variables to one side, the constants to the other. So I'm going to add 4x to both sides. So there's a plus 4x going here and a plus 4x going over here. And when I do that, I'll end up with 11x minus 21 equals negative 10. Then I'm going to add 21 to both sides. And when I do that, I'm going to have 11x equals 11. Divide both sides by 11. So I have x equals 1. Then for the check, we're just substituting in 1 for x. And then I'm just going to simplify my fractions. And when I get to this point here, honestly, as long as you put it into the calculator, it doesn't matter and get one side equal to the other, but this is the math. So I'm going to have to find a common denominator on the right-hand side, and then I reduce the left-hand side. Subtract on the right-hand side here, subtract those, that's where I get the negative 7 over 14. Then reduce, and that's a negative 1/2. So since that works, we know our answer can be 1. So when we solved this last equation, we were solving a linear equation with constants in the denominators. Oh, sorry, we solved that one. We were solving a linear equation with constants in the denominators. A rational equation includes at least one variable in the denominator. So like number 3. I have 6 over x plus 3 minus 5 over x minus 2 equals negative 20 over x squared plus x minus 6. So I have to factor my denominator over here. This x squared plus x minus 6 is going to be x plus 3, x minus 2. My factors of 6 that subtract to give me 1 are 3 and 2. The larger number takes the sign in the middle, so the 3 is the plus, and the 2 is the negative. So if you were to set those equal to 0 and solve, you would see that you can't have negative 3 or 2 for x. My LCD is one of everything I see, so in this case it's going to be x plus 3, x minus 2, and we'll use this denominator to clear the fractions in this equation. So I'm multiplying each side of the equation or each piece by it. I can put that parentheses there and that parentheses there, and then do another, if it's easier, x plus 3 and an x minus 2 there. So what's going to happen on the left-hand side is here the x plus 3's are going to cancel out. On the right-hand or the right side of the left side of the equation, sorry, I don't mean to be confusing, the x minus 2's cancel each other out. On the right-hand side, this whole entire thing will cancel with this whole entire thing because that's that factor. So I'm left with 6, because that was that numerator, times x minus 2 minus 5 times that x plus 3, which was left. And since everything canceled out, I'm just left with negative 20. The next step is to just distribute the 6 and distribute the negative 5. So I will get 6x minus 12 minus 5x minus 15 equals negative 20. Combine like terms on the left-hand side. So we have 6x and negative 5x will give me a positive x. And then I have a negative 12 and a negative 15, which will give me a negative 27 equals negative 20. Then I just need to add 27 to both sides. So x equals 7. All right. All right, my bad here. I have the wrong slide in the wrong order. We're going to skip this slide and I'll come back to it in a minute. So for example 4, we're solving 1 over x plus 1 equals 2 over x minus 1 minus 1 over x minus 1. We begin by factoring x squared minus 1 equals x plus 1, x minus 1, because this is a difference of two perfect squares. Therefore, x cannot equal negative 1 or 1. Our LCD is going to be x plus 1, x minus 1. So, again, if you need to, you can split this into two fractions or two separate terms and then do a x plus 1, x minus 1 by this one. Not necessary, but you can. On the left-hand side, the x plus 1's cancel out, so we're just left with x minus 1. For this next fraction, the whole thing is going to go with this whole thing, and here the x minus 1 goes with the x minus 1, so I'm just left with x plus 1. So I end up with x minus 1 equals 2 minus x minus 1. Just distribute that negative there, so everything changes to its opposite. And I'll have x minus 1 equals 2 minus x minus 1. Combine like terms on the right-hand side, so 2 minus 1, and I'm going to have to also move this x over, so add x to both sides. So I'll get 2x equals 2, and move this negative 1 over. So I kind of did a little bit of 3 steps in one there. I added the 1. And that got rid of that negative 1 here. And then I subtracted or added x to both sides. And that's what gave me the 2x equals 2. Divide by 2, so x is equal to 1. But if you recall from the slide before, we said you can't have 1 for an answer. Therefore, we have to reject it. And our solution set is what we call the empty set. We have the brackets. We don't put anything in there. You can say no solution, or you can say empty set. Both are acceptable answers. And then going back to those literal equations, we are solving for a variable, so we have to get all the other variables to the other side of the equation. So if I'm solving for Q here, 1 over P plus 1 over Q equals 1 over F. Okay, and this is an actual equation based on glasses. So it says, if you wear glasses, did you know that each lens has a measurement called its focal length, f? When an object is in focus, its distance from the lens, p, and the distance from the lens to the retina, q, satisfy the formula. So if we want to solve for q, we have to first multiply everything by the LCD. And the LCD in this case is just one of everything I see. So it's going to be P, Q, and F. So I multiply each term by P, Q, and F. So here the P cancels out with this one, the Q cancels out with this, and the last one, the F cancels out with that. So we are left with QF plus PF equals PQ. I am getting Q alone, which means I have to have all the Q's on one side and everything else on the other. So since this term here has a Q, I need to get it with this term. So I'm going to subtract QF from both sides so that both of my Q's are together. So subtract QF, subtract QF. So I have PF equals PQ minus QF. Since I need to get Q alone, I need to factor Q out of the right-hand side because there's a Q here and a Q here. So I just factor. If I divide both terms by Q, I'm left with P minus F. Then to get Q alone, I have to divide both sides by P minus F. So I have PF over P minus F. That's how I get Q alone. So give the U-tries a chance and see how you do. This last one might be a little tricky for you, but it's the same exact process.